Salam. Today, we will be doing the exercise of Chapter 2, Class 11 Statistics, according to PTB syllabus. Let's start by looking at the index. All the questions of this exercise are available on my channel. Do watch them for better understanding. Note, questions 2.17 and 18 are as short videos. Let's start with 2.4, where the question is 2.4 distinguish between one-way and two-way tables. Illustrate your answers with examples. Also, explain the following. Part 1. Classification according to attributes. Part 2. Class limits. Part 3. Length of class intervals. And Part 4. Class frequency. First, let me show the difference between one-way and two-way table. One-way is like any other normal table that is based on one characteristic. Like each fruit ate by what number of students? But in two-way table, two variables are interrelated like the fruits eaten by boys and girls. It is more detailed than the one-way table as it distinguishes the students into boys and girls. Now we need to explain Part 1. Classification according to attributes. This refers to the process of grouping data based on the qualitative characteristics or attributes that can't be measured numerically. Watch Lecture 2.1 plus 2.2 to recap the concept. Next is class limits. The upper and lower limits of a class are called class limits. Part 3. Length of class interval is equal to upper class limit minus lower class limit. And class frequency is the number of items falling in a class. Sounds familiar? If not, go check out Lecture 2.4 to understand the concept in detail. Question 2.5. The following table gives the details of the monthly budgets of two families. Represent these figures through a suitable diagram. Here, we will separately deal with Family A and Family B monthly budgets. First, we make a family a budget format analysis. We need to find the angles to get the sectors of the pie chart. To do so, we divide the amount of each category, like 600 for food, by the total 1500 and multiply by 360, which equals to 144 degrees. Like this, we complete the whole table and are done. Now we have all the angles of each category of the budget. We can now make a pie chart using a protector D. This is what it would look like. We label and differentiate each sector so that it's more attractive and understandable. Moving on to Family B, we just need to find the angles and tada. Here is the Family B pie chart. Next is 2.6, in which we also need to make a pie chart of the following data. So we need to find the angles of the sectors of the circle. Like for food, the angle is 4000 divided by 11100 and multiply by 360 degrees, which is 129.7 degrees. So the pie chart here is showing household expenditure. Let's move on to the next question. 2.7. Define a frequency histogram and draw frequency histogram for the following frequency distribution, giving the steps involved. A frequency histogram is a graphical representation of the distribution of data, where the data is divided into intervals, or classes, and the frequency of data points in each interval is represented by the height of bars. Before making a histogram, we need to find the class boundaries. And since the class width is 5, 37 minus 32 equals to 5, it means that the class boundary of a particular midpoint has a lower limit of 2.5 minus the midpoint and an upper limit 2.5 plus the midpoint. Here are all the class boundaries of the midpoints X in the histogram required. 2.8 is a lengthy question indeed, but let's do it. First, write down the important points for drawing graphs. B. In order to estimate the mean length of leaves from a certain tree, a sample of 100 leaves was chosen and their lengths are measured in millimeter. A grouped frequency table was set up and the results were as follows. Part 2. We need to display the table in form of frequency polygon and then find the boundaries of interval whose midpoint is 3.7 centimeters. For Part A, please recap Lecture 2.6. Now the core question is about the mean length of the leaves, for which we need to format a frequency polygon. In the frequency polygon, we just to place a dot where the midpoint corresponds with its frequency, and then connect all the dots by a line. Next, to find the class boundaries of 3.7 centimeters, we need to determine the class width. For example, 2.7 minus 2.2 equals 0.5, indicates a class width of 0.5 centimeter. The boundaries are calculated by subtracting and adding half the class width, which is 0.25 centimeter from the midpoint. Thus, the class boundaries are 3.45 and 3.95. Moving on to question 2.9. In a locality, total area is 500 acres where 250 acres are under sugarcane, 125 acres are under maize, 60 acres are under wheat and the remaining 65 acres are under other crops. Make a pie diagram to represent the distribution of acreage under different crops. Here is a table to find out the angles of each sector of the circle. We just need to divide the acreage of each crop divided by the total 500 and multiply by 360. Why by 360 you ask? As the whole circle is of 360 degree. Multiplying by 360 helps us check the angles of each sectors that will total to 360 degree circle. Here is the complete table and its pie chart. Now question 2.10. A biologist was interested to know whether male spiders are longer or female spiders. He collected random samples of female and male green lynx spiders, given below. Advise him? First of all, let X be length of female spiders, let Y be length of male spiders and convert all the data into a tabular format. Now we need to find the mean in order to find two average longer length spiders of each male and female. You will learn mean in detail in chapter 3. But let me just tell you a little to make this understandable. To find the mean we just add all the numbers of one category, like female spiders, and divide by the total number of female spiders which is 22, so the average length of female spiders is 5.86. Similarly, the average length of male spiders is 8.065. This shows that male spiders are longer than female spiders. Moving on to question 2.12. The following data gives the lifetime in minutes, recorded to the nearest tenth of a minute of 50 sprayed insects. Form a frequency distribution and a cumulative frequency distribution. And also draw histogram and frequency polygon for the frequency distribution formed. First of all, we need to find the minimum and maximum value in the data, which is 0.2 and 6.3 respectively. We calculate the range, which is 6.1. So the width or the length of the class interval is 6.1 divided by 8, as we need to form 8 classes. So the answer is approximately 0.8. Here are all the classes formed in their corresponding frequencies. Next we add the class boundaries to this table. This is a simple frequency distribution table. After that we add the cumulative frequency column, in which we just add all the preceding frequencies into the next until we get the total frequency, which is 50. Now this is a cumulative frequency distribution table. Moving on to the next part of the question, we need to make a histogram. For that, we use the class boundaries to make all the bars of the histogram side by side. The height of each bar shows the frequencies. To mark a frequency polygon, we need to find the midpoints of the class intervals. For that, we add the upper and lower limit of a class and divide it by 2. Now this is how the frequency polygon is formed. Question 2.14. The following data gives the record of a company's savings over the years. Draw a bar diagram to represent it. This is simple. Put the years on the x-axis and savings on the y-axis. Now draw the height of the bars each year according the corresponding frequencies. 2.15. Draw a subdivided bar diagram to represent the male and female population of 4 divisions of Punjab in 1961. In subdivided, we make a single bar having both variables, as here are male and female, and subdivide the bar into the components. Here is the subdivided bar diagram of the given data. Pink represent the females of the divisions and blue is used for males. Next is 2.16. The following information is available about the age, in years, and their weights in kilograms. Make a scatter plot and bivariate frequency distribution. First let's make the scatter plot. For that we put the age on x-axis as an independent variable and weight on y-axis as the dependent variable. All the data set is shown here in form of a table for easy understanding of the data. In scatter plot we plot a point at the exact location where the age and the weight coincide. Now for bivariate distribution, we first need to find the smallest and the largest data sets. The smallest in age is 14 and largest is 24, and smallest y is 45 and largest is 75. Thus here is the bivariate frequency distribution table made using tally marks. We have made a few class intervals for weight and age according to our requirements. Suppose we have data set 20,60, so we place a tally mark here where the class interval of age and weight coincides. Similarly, we tally mark each data set in the table. We can also use a numbered bivariate frequency distribution table like this. I hope this lecture was helpful. Don't forget to subscribe.